It's probably not a fate many of us want to think about, but have you ever wondered what would happen if an asteroid headed towards Earth? 66 million years ago, the dinosaurs confronted that very scenario, and of course it didn't end well. Now that NASA wants to test a so-called planetary defence system to prevent humanity going the same way, it's launching a spacecraft directly at an asteroid to see if it can be pushed off course.
This is the first time SpaceX has taken a NASA spacecraft and intentionally launched it on a trajectory to escape Earth and crash into an asteroid. So again, pretty cool mission.
It is pretty cool. Scientists have identified a pair of asteroids known as the Didymos system, which orbits the Sun. They don't pose a threat to us, but they are a good testing ground. In their travels, the asteroids sometimes pass relatively close to Earth. Around the end of next September, they will be less than 11 million kilometres away. So NASA wants to test what happens if they smash the so-called DART spacecraft into the smaller of the two asteroids, Dimorphos. Before the impact, a tiny satellite will shoot off from the main spacecraft to capture images of the collision and the resulting blast of debris. Scientists will then examine whether the impact alters the course of that asteroid and by how much.
We know how we're going to hit in the trajectory, right? We're hitting it head on. But the problem is that we cannot predict whether there's going to be a boulder or something. So our impact angle on the plane of Dimorphos is really uncertain right now. And it's really going to depend on what Dimorphos actually looks like. And we're not going to find that out until the last, well, let's be honest, last 20 seconds when we're about to hit.
So at stake in all of this is whether humanity could successfully avoid a potentially catastrophic collision. Scientists think a single deflection mission probably wouldn't be enough, but it will give scientists an idea of what to do next.
This is a test. We don't want to be in a situation where an asteroid is headed toward Earth and then have to be testing this kind of capability.
Let's unpack more of this now with Dr. Rebecca Allen, astronomer from Swinburne University of Technology. Dr. Allen, thank you so much for joining us. This does get someone wondering, what is the likelihood of an asteroid smashing into Earth anytime soon?
Well, look, as we've seen historically, there's a lot of very large asteroids which have made close flybys, but it's been comfortably tens of millions of years, not so great for the dinosaurs, but for us, we're okay, since a really catastrophic impact event has happened. Now, that doesn't mean that one couldn't happen in our lifetimes. And unfortunately, as we've seen with asteroids, they can be very difficult to detect until they're very close to us. Hence, NASA's mission, so that if we do find one within a few years, we could hopefully steer it off course from hitting Earth.
Realistically, how successful could that mission possibly be when you're talking about the sort of velocity and mass of comets and asteroids?
Well, this is why it's really important for us to be able to accumulate as much information about the asteroid ahead of the mission. And so NASA's done a really great job of picking this asteroid pair so that we can really carefully understand, just what the characteristics of these asteroids are like, and then what happens after DART makes impact. And so it's going to be critical as we learn from this mission, just how successful it was, because like we said, like was said in your intro, one hit may not be enough. And so it may take successive missions. And so this is where we really have to understand, is that exact 6 kilometers a second? Is that going to be enough to push a 100-meter asteroid, nudge its orbit, or is it going to take more? And so I think that's where the real unknown of this comes into play. However, we've seen NASA successfully land, many rovers on another planet. And so I'm not too worried that, we'll have that precision of that impact. It's just going to be about what happens afterwards.
For those of us who don't know this stuff deeply and intimately, the technology around this is really quite extraordinary, isn't it?
I know I hate to use the, the comparison, but it really is cosmic billiards. And so what's happening is that we believe, as astronomers, that there's many different ways that you could move an asteroid. But the idea that you don't really want to disrupt the asteroid, as we've seen in the Hollywood movies where you set off a nuclear explosive. It seems much more practical that you would just try to slightly nudge its orbit. But that requires a lot of precision calculations because you want to hit the asteroid in just the right way, like in billiards. You want to hit that ball in just the right spot at just the right speed. And so that's where a lot of calculations and simulations have come in to play. But also the technology that we see aboard this spacecraft is the result of many missions before it, such as the Dawn spacecraft, which went on to investigate Vesta and Ceres, two of the most massive asteroids that we know of. So it's taken these missions before to successfully, demonstrate this technology to now where we see these cameras, these algorithms, which will allow the spacecraft to autonomously navigate once it approaches that system. And so again, it's the legacy of all of these past missions that have come into play. So we're going to see some really incredible technology demonstrators along with the mission demonstrator.
What goes into the making of a spacecraft that is designed to be crashed and ruined?
Well, I hate to think of its fate, but really what we're seeing here is years, if not decades worth of planning and testing. And that's why I talk about the missions that have come before, because to just, kind of have a bespoke spacecraft, as we've seen with the James Webb Telescope, for example, that's decades of work. And we've seen, with the Cassini spacecraft that went to Saturn, you see mission scientists who have been working on a project for 30 years and they're getting to see the results. Now, what we want to see, especially with something where we would want to have to act immediately to deter an asteroid, you don't want to be taking, brand new technology. You really want it to be something that's more off the shelf. And that has to do with the speed of the mission, and it also has to do with the cost of the technology that goes into it. Now, this mission, this spacecraft, the body of the spacecraft is only about 1 cubic meter. So that really shows how we've been able to miniaturize technology over time to create a compact and very effective mission and the technology on board. So the spacecraft really only has one camera. And so that's what will be used to kind of navigate as it gets closer to the system. But it will also be launching a much smaller spacecraft as it approaches, which is called a CubeSat. So a tiny CubeSat will actually be monitoring the impact of DART and will give us, kind of real time as you can get, being 11 million kilometers away. But we'll get to see the footage of that. And that's all thanks to this incredible advancement of technology over decades.